Okay, now let's do this problem number 3 right here. Let me make sure it's zoomed in. Okay, so question number 3, I'll do 3. Yeah. So question number 3 says, calculate the volume occupied by 25.2 grams of carbon dioxide at 0.84 atmosphere and 25 degrees Celsius. Okay, so let me just start with the givens. Let me start with the easier one. The pressure is 0.84 atmospheres. The temperature is 25 degrees Celsius, which I always have to do in kelvins. Changing Celsius to kelvins, add 273, and this would be 298 kelvins. Then we have, there's one other thing on here that is, I have 25.2 grams of carbon dioxide. Okay, so those are my 3 givens right now. That is not it's not a temperature, that's not pressure, and that is not a volume. I'm trying to find a volume. So we are trying to solve for V. That's the question. What is the volume? That's a question mark. That's supposed to be a question. V equals question mark. Okay, that's the question. What is volume? So what equation will I have to use for this? Well, all the different equations I have to use, of the equations, I have pretty much just the combined gas law and the ideal gas law. And the combined gas law is if I change pressure, volume, and moles or temperature. Heat it up, cool it down, increase pressure, increase volume, decrease volume. Ideal gas law is the gas is just there. You're not doing anything to it, you're not changing anything to it. And if you're not changing anything to it, then that's where we use the ideal gas law. In this problem, notice it just says what's the volume of this gas? It's just there. You're not heating it up, you're not cooling it down, you're not doing anything to it, unlike question number 2, where it says, hey, the volume change, or so what is a new volume, even though you already had volume? The pressure change, the temperature change. That's what question number 2 was. In number 3, nothing's changing. It's just there. So if nothing's changing, we have to use the equation, the ideal gas law. PV equals nRT. PV equals nRT. We are solving for volume, so in this case, we're solving for V. And since we're solving for V, volume will equal to nRT over P. Well, there's a few things I already know. I know P, I know T, I know P, I know T. You also know R. Even though it doesn't say it outright, R is a gas constant. R is something on the test, I would give it to you what R is. It's a gas constant, kind of like if you're told like, hey, area is equal to pi r squared. You know what pi is. Pi is a constant. Pi is 3.14, okay, and more digits. Well, R is a constant. R is equal to 0.0821 liters atmospheres per mole Kelvin. On the test, that's a K, that should be moles Kelvin, not liters. Liters atmospheres per mole Kelvin. That's what R is, and that's always R. So I know P, I know T, I know R. There's one other thing I need to find, N, the number of moles. I have a number of this gas, carbon dioxide. I have a number of grams of carbon dioxide, but I'm not trying to find the number of grams of carbon dioxide. I'm trying to find the number of moles of carbon dioxide, N. And if I can change grams to moles, N, then I'll know N, I know R, I know T, I know P. I can plug it in and solve for volume. Okay. Sorry, that's for the top question there. Okay, so, well, let's change grams to moles. Well, we know how to change grams to moles. That's from chapter 3, the stoichiometry thing. Change grams to moles. To change grams to moles or moles to grams, the first thing I need to always find is the molar mass. The molar mass, in this case, carbon dioxide. Look up the molar mass of carbon, add to it 2 times the molar mass of oxygen. Carbon on a periodic table, you want to need a periodic table for this. Carbon on a periodic table, 12.01. Oxygen in the periodic table, 16, but times 2 because it's 2 oxygens. Add that up, and that's 44.01. 1 mole of carbon dioxide is 44.01 grams. And I only know that by adding up from the periodic table. 1 carbon and 2 oxygens. 12 plus 2 times 16, 12.01 plus 2 times 16 is 44.01. Then my grams of carbon dioxide will cancel, and it'll be, I don't know what it is, I need a calculator for that, whatever 25.2 divided by 44.01 is, and I get 0.573. I'm just doing 3 sig figs. Well, because it's supposed to be 3 sig figs. 0.573. 573 moles of the gas. So, I don't want to get that mixed up. Okay, so the number of moles, N, is equal to 0.573, P, 0.84 atmospheres, T, 298 kelvins, R, 0.0821 liters atmospheres per mole Kelvin. I can plug into the equation now. V is equal to nRT over P. So plug it in and see what you get. N, again, is 0.573 moles. R, 0.0821 liters atmosphere per mole Kelvin. The temperature is 298 kelvins. All over. P was 0.84 atmospheres. Some of the units cancel out, like moles and moles, kelvins and kelvins, atmospheres and atmospheres. The only unit that does not cancel out are liters. And notice all my choices are in liters. So the volume will equal to, I need a calculator for this. And what was the answer? I don't know. Let me plug in my calculator now. It's going to be 0.573 times 0.0821 times 298 divided by 0.84. And I had 16.7, 16 point, oh, I'm sure I rounded something weird. 16.9. Okay, I don't know where I probably rounded somewhere weird, but 16.7. I'm sure I probably plugged in something wrong somewhere. 298. Sorry, I'm just doing it again. Okay, so it's just a rounding thing, but yeah, that's why I got 16.7, but 16.9, close enough. Okay, for this one, considering none of the other choices are even that close. Okay, 16.7 liters. Okay, let me try question number 4 and 5 before it ruins this thing and I can't, like crashes again. Sorry, these wires are everywhere. Okay, so question number 4 says calculate the density in grams per liter of SF6 gas at 27 degrees Celsius and 0.5 atmospheres. Okay, so this goes back to the equation that you had to use. That the equation is, well, the only thing that has density in it, actually, maybe I should write this down. So I'm trying to find density. I know the gas, SF6. I know the temperature was 27 degrees Celsius. I know the pressure is 0.5 atmospheres. Convert Celsius, I probably shouldn't use this light color blue. 27 degrees Celsius is same as 27 plus 273. I don't want to, too lazy to think, is 300 kelvins. Okay, so I have the Kelvin temperature. I'm trying to find density. And so the density equation for this, well, you would have to either look it up and so I can look this thing up. Hold on. If I Okay, sorry, I had to grab the book. So the equation for density is equal to pressure times molar mass of a gas divided by RT. The density of a gas is equal to pressure times molar mass of the gas over RT. That was also in the notes when I went over it before. So let me write down that equation again. Density is equal to pressure times molar mass of the gas over RT. So, sorry, I had to grab the book earlier. Okay, so I know the pressure, you know R. Actually, let me circle R. It's right there from before. We know pressure, we know R, we know temperature. I just need to know molar mass of the gas. Well, I know the gas. It's SF6. It's sulfur plus 6 fluorines. Sulfur is 32.06. And 6 times fluorine. Fluorine was, I forgot right now, but that's okay. I have a periodic table inside the book. Fluorine was 19.00. Sulfur, 32.07. I wrote 32.06, whatever, close enough. 0.07 plus 6 times 19. The molar mass of the gas added up, 32.07 plus 6 times 19. The molar mass of the gas is 146.07 grams per mole. Now I know M, I know P, I know T, I know R. Plug into this equation right there. So plug into the equation. So I'm kind of running out of space. Sorry. Okay, so density is equal to P, which is 0.5 atmospheres. M, which is 146.07 grams per mole, all over R, 0.0821 liters atmospheres per mole Kelvin. And T, which is 300 kelvins. Notice some of these units cancel out. Kelvins and kelvins cancel. Moles and moles cancel. Atmospheres and atmospheres cancel. The only thing that doesn't cancel, grams over liters. So what is the answer for this thing? You need to plug in a calculator. And for that, it will be whatever 0.5 times 146.07 divided by 0.0821, and 300 is, and that I got 2.96. Oh, good. That's one of the choices. 2.96 grams per liter. Okay, last question. Try to do this fast. Okay. What's the molar mass of Freon 11 gas if the density is 6.13 grams per liter at STP? I don't know what Freon 11 gas is. And the point isn't to look it up. It's kind of like your unknown gas. You're trying to find its molar mass. Again, the equation was D is equal to PM over RT, but I'm trying to solve for molar mass, not D. This is the same as molar mass is equal to DRT over P. So I need to know the density. Well, I know the density was given. The density was 6.13 grams per liter. I need to know R. We always know R. Okay, always 0.0821 liters atmospheres per mole Kelvin. I need to know the temperature and pressure. Well, I also know that too. The temperature and pressure, how do I know? It says it's STP. STP is defined as 0 degrees Celsius and 1 atmosphere, or 273 kelvins and 1 atmosphere. Now that I know that, I can plug everything into the equation. Molar mass is equal to D, 6.13 grams per liter. R, 0.0821 liters atmospheres per mole Kelvin. Sorry if my handwriting's ugly. Temperature, 273 kelvins. All over the pressure, 1 atmosphere. And notice the units, atmospheres cancel, kelvins cancel, liters cancel, and the only thing you have left are grams per mole. Molar mass is measured in grams per mole. It'll be whatever 6.13 times 0.0821 times 273 divided by 1, I didn't have to do divide by 1, is, and I got 137 points. 137, good enough. Oh, look at that, that's one of the choices. 137 grams per mole. And that's it for now.